Hello Redshifters. Redshift 2640 introduces per particle support for the MASH instance. But before going into that, I'm going to show you what per particle means. And for this, we're going to create a particle system. Now, there are two particle systems in Maya. One is the legacy particle, or the old traditional particles, and then the end particles. The end particles are a bit more sophisticated. They have more controls. They can do a lot more things than the traditional particles. But the traditional particles are the most stripped down particles, so you have to create a lot of things to get even close to what the end particles can do. That's why I'm going to use the traditional particles for this. Okay, so we have a volume emitter that just shoots out particles. And of course, if I try to render this, all the particles will be exactly the same with a radius of 1. Although we have points here. If we switch to spheres, you're gonna notice that, well, this now obeys the radius, and this obeys the radius because there is an internal radius for this, which is 0.5. Otherwise, it would have been 1, as you can see here. Now, this is not a big deal. The problem is that, well, having all the particles have the same radius is not funny, okay? And we want more. So the way particles work in Maya is as the following. Each frame, one or more emitters emits some particle. Each particle has what we call the particle ID. So if I switch to numeric here, you're gonna see that what you see here, it's a particle ID. Now, usually the particle IDs are unique, so you have from 0 to the number of particles minus 1. So in this case, from 0 to 457, okay, because we have 458 particles in total. And just to show it to you, I'm gonna emit one frame. So 0, 1, 2, 3 in total, which makes 4. Okay, so these particle IDs are really important, because we're going to associate this with something used in MASH. Okay, now these are usually object attributes like the radius, like a point size or something like this. You can even have a global color for your object. Let's say the spheres are red. Okay, but again, not fun at all. Okay, so what we want to do is use per particle attributes instead, and these per particle attributes will create an attribute or a value of the attribute for each particle ID. So they associate some attributes values with a specific particle ID. Okay, so let's say I want a color per particle color, and I'm going to use here RGBPP. That's the color in Maya particles. And as you can see here, the RGBPP seems to be, in this case, 100. So if I render this, they should be red, right? They're not red. And if you're asking why they're not red, is because, well, for the moment, there's no shader telling Redshift what to use and how. So let's create a shader for it. So I'm going to assign a Redshift material. And again, for the moment, it's still the same. Of course, you can change the color if you want. Not a big deal, but you want to use the per particle attributes that we just created. So I'm going to add the user data color. And the user data color will look for an attribute. Well, not specified, so it's the default value, so we can put again whatever value we want here, but it's still an object. Same value for all the particles, so I'm going to look for RGBPP. Okay, and as you can see here, we associate this value, which is 100, which is exactly red, to the RGBPP. And that is because we have this as an object attribute, but we also have it as a per particle attribute, but it's not initialized. And that means we need some sort of expression to get that working. So RGBPP equals, it's a vector, 0, 1, 0. That means there will be green. Again, no variation for the moment. So if we rewind this, 0, 1, 0, everything is green. Okay, we don't want that. We would want some random colors. So I'm gonna use rand of 1, rand of 1, and rand of 1. Okay, and that means we're gonna get some different colors, and you can see that by switching to sphere modes. And there you go. And you're gonna get exactly the same colors here. And that's perfect. We want something similar in our MASH instancer. So somehow we're thinking about, how about for each particle ID, we associate the particle ID with these values. That should be interesting. Okay, so let's see how that will work. By the way, when you're getting, well, kind of like you're trying to use attributes from the per particle attributes, we only support a few, and those few are color, opacity, and these user scalar and these user vector. Okay, if you create something else, for instance, we have radius here. All the particles are the same, right? I can create a radius pp. These are pretty fine, and you can create whatever you want. Let's get the radius pp. Okay, and the radius pp, let's create an expression for it. Radius pp equals rand between 0.1 and 0.6. Okay, edit, close, rewind, and we have a bunch of them. That's perfect, and it works. Okay, but let's say I'm gonna try to get this guy here in a shader somehow, right? So how can we do that? Let's say I want to use a user data scalar, because the radius pp is a scalar node, right? So I'm gonna type in here radius pp, and I'm gonna use this for, let's say, for diffuse weight. Why not? Okay, so it will be somewhere between 0.1 and 0.6. Actually, I can make it 0.6, doesn't matter. Okay, and I'm gonna try to render this, and I'm getting nothing. And the reason I'm getting nothing is because there are some, besides those 12 attributes that I've shown to you, we can't read these directly, so we have to use a trick. So for this, because this is a scalar one, I'm gonna create a scalar attribute that we do support. For instance, user scalar 1 pp. And all I'm gonna do, I'm gonna say user scalar 1 pp equals radius pp. So we're defining radius pp here, and then we're saying that the scalar pp is equals the radius pp. And then we can indeed have a different, well, of course, we have to rewind part first. We can have a different value. Now, this is radius pp, right? We don't read that, so we have to type in user scalar 1 pp. And this time, this will work. And as you can see here, they're more or less, well, the bigger the radius, the more diffuse they have. The smaller the radius, the less diffuse they have, right? It's not the best attribute in the world right here, but it's something that you can visualize and associate with the color, and in this case, kind of a luminance if you want. It's not the luminance, it's just the multiplier of the actual color of the diffuse channel. Okay, so let's put this back on 1. So this is kind of the way per particle attributes work. Okay, that's great. How about the MASH instancer? Let me hide these two guys. And by the way, before going to MASH instancer, I'm just gonna show you a cube, hopefully, and I'm gonna instance that cube. These are my particles. I'm gonna select the cube, and the particles and particle instances. And we get that. And that's fantastic. I've instanced one cube into many cubes, and it looks, well, not that interesting. Okay, and we'll start thinking, okay, I have a radius pp, I can use this into the instancer as a scale, but it doesn't see here because, well, this is a scalar and this is a vector. The scale is a vector, radius pp is a scalar, so how about allow all data types, and then I can use the radius pp, if I can find it, radius pp. And there you go, each cube has a different radius. And for the moment we have the particles in sphere mode, so let me just put this in points, and that's fine, but they all rotate the same way, so we have to create another attribute. Let's call it rotation pp or rot pp, and this will be a per particle attribute, a vector, add, close, create an expression, rot pp equals a vector rand of 360 degrees, rand of 360, and of course in the end a rand of 360. Okay, and this will give us a random vector between 0 and 360 on all three axes. And of course we have to rewind and set the rotation to rot pp, and we get this, and that's fine. If you want to animate this, it's a bit more complicated because this is the expression at creation. At runtime you have to do something a bit more complicated. So let's say another expression plus equals, I'm gonna add for each frame let's say 5 degrees. See, and this becomes a bit of a nightmare because you have to animate these, and you have to animate them sometimes in expression. You have to create other attributes to control expressions and so on and so forth. This can be, well, it's no joy if you don't know what you're doing. Okay, it's extremely powerful, but again, no joy. So if I have to render this, and I'm gonna use that cube and assign the existing RSMat1, the instances will pick up the color from the particle system. Well, because the material of the actual object, the actual cube, is this, looking for RGBPP that exists on our particles. Okay, and that's fine. I mean, if I don't want to use this, just to show you again, this user scalar 1, I'm gonna put this into the emission color. Okay, and emission color, let's put this on R, just on red. Okay, and overall 1, and I'm gonna get random values from black to pure red. Kind of, it never goes to pure red, but it's okay. I mean, it never goes to pure red because the actual value of the radius pp, which gets passed to the shader through the user scalar 1 pp, is from 0.1 to 6.6, so 0 to 1 actually. Rewind this and we're gonna get something a bit more, so bigger, red, more, well, a lot more red, smaller, less red, and so on and so forth. Not ideal. Okay, so let's get, and this is frankly not quite nice to see. So emission weight back to 0, and we're back to the RGB. Of course, this should be weight of 1. Now, how about trying to pass all this to something different, right? So the way we associate these attributes is through the particle IDs. Now, when you're emitting one particle, let me hide the instancer and emit some particles. When you're emitting some particles, each particle has an ID or an identifier. Okay, and I can see that if I switch to numeric mode, and this is fine. We're associating some particle ID to some values, RGBPP, for instance, or radius PP. That's fine. And this is what we should do with mesh as well. Okay, so let me get back to spheres. And let's create a cube. Actually, we have a cube. And this time, I'm gonna use a mesh instancer. Okay, and we get these 10 instances. They're not copies, they're instances. When you're using a mesh instancer, you don't have access to the color node, which varies color across the copies. This is only working for the mesh repro node, which has its advantage, that's being one of them, right? But it creates copies of the geometries, and it's absolutely not very efficient in terms of rendering, because it creates a ton of polygons when you can use just instances. Anyway, we have these guys, right? I can put here a random and do the same thing I did with expressions, but with a few clicks. There you go. Okay, and I can do this for the scale, and it can be uniform scale and so on. That's fine. But still, these are not varied across the instances. You see that the particles vary their color, but still the mesh instancer does not, although it's trying to use an RGBPP, which does not exist on the mesh instancer at all. So what can we do about it? Well, because 2640 introduces this per particle support, all we have to do is associate something, some particle system, to the mesh. Before showing it to you, I'm going to show you something a bit more interesting. I can create a point ID. Okay, and what this does, it shows me for each mesh instance the ID. Okay, so I have 0, 1, 2, 3, blah, 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 up to 9. And this is mighty interesting because we can vary the distribution. Let's make this spherical approach and make this into 200 particles, 200 instances. And each particle ID is unique, and that's the beauty of it. I can associate this point ID with some particle IDs. So check this out. Numeric particle ID. Okay, so just imagine whatever the object ID number 0 holds, Redshift will look for the associated particle ID number 0, and the data that it has on the particle ID number 0. That's mighty smart. So how does it end? Well, first we have generated 4 particles with 4 particle IDs and 4 random values. For sure, this won't work. I mean, I can tell you from now that it won't work because I haven't associated yet anything to the mesh instancer. What we have to do is drag the particles in here. Okay, and now if you're we're testing this, we're gonna see that the first 4 objects do have indeed some colors. Well, actually probably more than this, maybe we're cycling or something, but yeah, and we're regenerating every frame. It's a bit inconsistent, and probably the reason for this is we have a lot more. We have 200 instances but only 4 IDs. So what I suggest in this case is that we emit more. Okay, let's emit some huge numbers, and when we specify the particles to be only 200. Actually, I think I typed this as being a huge amount. Yeah. So let's try this. Okay, we've emitted 200 particles. Each one has a different value, right? And now, actually I can hide this because we don't need to see it. And now, because we have these 200 values, what do you know? We have, and this will be consistent, by the way, okay, we have per particle data fed into a MASH instancer. And of course you can use the same thing. You can use the user scalar one or user scalar or user vector PP's attributes there to vary things around. For instance, let's do something quite nice. I don't want random values, I want some values, right? And I don't want to go to the particles and try to figure out a way to write an expression that uses not some random values but some specific values. No, I want something a bit more simple. So I'm gonna remove this and create another expression. So user scalar 1 pp equals floor of rand of 10. Okay, so the rand of 10 will create values from 0 to 10 up to 10 but never 10, and floor says if the value is 2.2 or 2.8 it will be floored to 2. Okay, so edit this, and if you're looking at the particle ID, not the particle ID, the user scalar 1, that's user scalar 1 pp here, you're gonna notice that we're gonna have some values, so from 0 to 9. Okay, and that's interesting, but the thing is, okay, 0 to 9, maybe it's not ideal. Maybe I need, instead of the reason I'm doing this is because I can use a shader switch. Okay, and the shader switch has values from 0 to 9. See? So what I can do here, and these can be various shaders, I'm gonna use plain color, so I can use this, of course, on the cube. Where's the cube? Here. And if I try to render it, it will be white. Well, except those particles we can hide. Okay, so we don't want this to be white, we want different colors, and I'm gonna just pick these guys from top. Nothing spectacular about them, they're just some colors, and they're a bit different. So far we have RGB, cyan, yellow, magenta, and let's try to find something of a blue, and probably two more, which frankly speaking it will be this and probably this purple. Okay, so we have 10 different colors. Of course this will be just the first color, which is red, and if I go from this user scalar to the selector, I'm gonna get a different value for each user scalar. And of course the user scalar, remember, is from 0 to 8 because we floored it. If we're looking at the particle here, we said it's floored of rand of 10. Frankly speaking, this creates values from 0 to 9 for 10 objects. If you want 20 objects, it will create from 0 to 19. So no big deal, it's simple math. Okay, so we have managed to create actually some way of varying even shaders. We can put here 10 different shaders on different objects in the actually the same object, just different shaders on the same object. Let's make this a bit more complicated by adding a sphere and whatnot, a cone. Okay, and of course these are not in the MASH network yet, but we can add them. So we select these two and the MASH instancer and go add selection. Bam. Of course there's no change because, well, the MASH doesn't use any ID, so I'm gonna go for ID here, and now I'm gonna, frankly what this does is repeating the ID 012 012 012. Oh, I want this on random. Okay, so what we did here is, let me hide this, we have 3 different objects and each object uses a different shader. Okay, now we're not seeing this because we haven't assigned the same shader, the shader switch, to these objects, and now we do. Okay, so let me try to run this again. So we're initializing the particles and we get everything working nicely. So this is the way you're actually making the particles to inject data into the MASH instancer. You just drag it here, or you can simply type it, but you need to create these particle per particle attributes on the particle system. Okay, they might not do much, but if they exist, you can extract color, opacity, user scalar 1 and from 1 to 5, and user vector 1 to 5, and that's about it. I mean, I think that 12 attributes might be enough. I don't know why we can't read more than this. Maybe it's a limitation. We're gonna see if we can add more in the future. But basically, yeah, that's how you're injecting per particle data into a MASH network. But this is using just a simple a simple distribution, okay, which is a spherical distribution. You can use a mesh to kind of create a surface emitter. You can use in position PP, and this is more interesting, right? So let me just get the particles and the mesh. And before doing this, I'm gonna copy the tab here. So you see here it says spherical, right? I'm gonna select the actual particles and the mesh and go to the mesh utilities, connect the particles to mesh, and look at here, distribution type. It changes to in position PP, and that means the actual particles and the mesh network will share the same position. And this is nice because you can actually verify that the particle ID, I don't know how to make it more visible than this, the particle ID and the point ID are the same. So see here it says 87 on the point ID, okay, and it says 3 on the actual particle ID. So somehow we do associate things, might not be exactly the same, but you know what, this basically works. Okay, and now we're using particles. You can have dynamics, you can have a lot of things, and this works, by the way, even if you do something a bit more complex. In this case, we're just using a simple distribution, which is an in position PP. You can use something a bit more complicated. You can go here for a world node, okay, and this can be a bit of an issue. Let me just get a plane, because you're just trying to do a terrain and some vegetation. So MASH, okay, we're gonna use a terrestrial ecosystem, and you can see here this is spread across everything. Let me just hide the particles and hide the, actually I can leave the MASH points. No, they're too much. So we're on this world, okay, and of course we're using, as you can see here, we're not using a cluster. We're interested into the input mesh here, right? So I'm gonna drag the plane in here, bam, and this should create the actual thing on the plane. I hope. If it doesn't, let's break the connection and do this on the on the distribute. That should work. It doesn't matter. This should work here if I drag the plane on the input mesh. It should give me this on the actual surface. I don't know why it doesn't work. Anyway, it's not that important that I make this work or not. What is important is that you have a terrestrial ecosystem, and this kind of works with a lot of copies, a lot of instances, and you can use the exact same thing to create to inject your per particle data into an ecosystem. I have done this in the past and it works just nice. In the past I didn't have the per particle data, so I had to actually create the copies of the same object with a slightly different shader, and then vary the copies as object IDs and so on and so forth. But now with the actual particle and with the per particle data, we can vary this a bit further, and it's really nice. So guys, this is how the MASH instancer works with the particle system. So just either drag it in or type it in, and this will just inject the per particle data from a particle system into the MASH network. Just make sure that you have enough IDs so the MASH instancer doesn't go crazy. And in this case, for instance, we have, I think, enough points. Well, we have a lot of points here. Frankly speaking, I don't know how many we have, but there's quite a lot of them. And the thing is, you need to make sure that you have enough particles. In this case, we have just 200, and these are like a few thousand. Okay, so just make sure that you're emitting enough particles for this, and you can emit all the particles in one frame, or you can emit them across multiple frames. But frankly speaking, you can just emit some bunch of random numbers of particles across one frame, and you're done with it. Okay, so that's how it works. Of course, as always, if you have any questions, just put them on the forum. We're there to help you. Happy redshift, guys. Cheers.